Alright, I'm going to talk about the second law of thermodynamics, SECOND, second LAW second law of thermodynamics. Dynamics. It's just like the money game. Let's say this is you. Let's say this is you, and this is your neighbor. All right. So this guy has a billions of dollar here. Billions of dollar. He has $1 billion money here. Billions of dollar money there, right? And he gave you $100. Suppose he gave you $100. $100. Out of this $100, let's say you spend about $20 to buy books, and other $80 you lost. $80 you lost. You see that? So there is a guy who has billions of dollar. So he gave you $100. Out of that $100, you bought a book with $20, but $80 of that money you lost. You see that? How much you lost? $80 you lost. How much you used? $20. How much you got? $100. So what is the efficiency of money management here? So your efficiency is how efficient you are in money management. This is waste. This is WAST, waste. This is good. You bought a book, right? And you got this much. So your efficiency in money managing is how much? $20. So that's a useful, and out of $100. So you see that, then it's equals to 20%. So your efficiency is about 20%. If you have to manage the money, your money management efficiency is 20%. So this is called the second law of thermodynamics. Let's talk how it is this concept in physics, chemistry, and engineering. All right. So this is an engine. This is an engine like a motor engine, motorbike engine, or whatever, right? And inside this is some gas here. Could be water vapor, or other kind of the gas. All right. So here is a tremendous amount of this is a container that has a tremendous amount of heat. A large amount of heat is here. We call it a heat reservoir. No matter how much heat it gives to this engine, the heat doesn't get depleted there, so it remains the same amount of, a lot of heat is here, right? And this is the engine. So this heat reservoir gives, let's say, 100 joule of heat to this engine, and there is a motor. Inside motor there is a thing that rotates. All right, that rotates. So once it gets the heat, this gas expand, and this wheel and axle start to rotate and drives the car. All right, so let's say out of this 100 joule of heat energy, this engine uses to drive the car about let's say 20 joule of heat energy. You see that 20 joule of heat energy is used to drive the car here, but other 80 joule of energy here is lost as heat to the outside. This engine lost other 80 joule of heat to the outside environment, but change 20 joule of heat energy into real work to drive the car here. You see that? So in the thermodynamics we call this as a work. This we call is work, and this is a heat lost. So we call this is a QC, the heat lost in cold environment outside, and this is we call heat absorbed in high temperature reservoir. This is we call QH. The heat received is called QH, that is 100 joule. The heat lost by that engine is to the cold environment, Q cold equals to 80 joule, and 20 joule is converted into the work. Now let's calculate the efficiency of this machine. So what is the efficiency of the machine? So we write that efficiency is N. So that is work divided by the, how much he got it here? 100 joule. 100, right? 100 meaning that it took 100 joule of heat energy from this heat reservoir. So work is 20 by 100 is equals to 20%. So this engine has a 20% efficiency. See that? About 100 joule of heat energy is absorbed by this heat engine, and only 20 joule of heat energy is used to drive that car, but 80 joule of heat energy is lost to the environment. And when we calculate the efficiency of that engine, that is the work that we produce here divided by the heat we absorb here, and that is equals to 20%. This is the investment, this is the useful work we got, and this is the waste. So this, according to second law of thermodynamics, this QC cannot be zero. This QC cannot be zero, and this percentage, this efficiency percentage, that we call this efficiency, it cannot be 100%. This cannot be 100%. This QC cannot be zero. So that's all about the second law of thermodynamics. Thank you very much.